Hello. I'll start in a couple minutes.
You see.
Yeah.
Don't worry.
We'll wait another minute and then we can start.
Que Nah, yeah.
Okay, we'll start now. Today's lesson is about galaxies in the universe. So we'll be learning all about the composition of galaxies, how galaxies were originally formed, and things like that. So first we'll start with the universe. Can you please mute?
Bluetooth.
We'll have questions afterwards. So first we'll start with what the universe actually is. And the universe is basically encompasses everything included in space, including stars and galaxies and planets. It also includes energy like light and matter, which is basically any physical substance. If you have any questions, you can raise your hand and then unmute. So first, we'll start with the Big Bang Theory. The Big Bang Theory is the most commonly accepted theory for the formation of the universe, and it states that the universe started from one infinitely small point called a singularity, and then from that point expanded and basically exploded with a lot of energy to create the universe as we know it now. And as the matter expanded and exploded, it was originally very, very hot. So that heat first needed to cool down for molecules to start bonding with each other and for atoms to start forming. But basically after the Big Bang, as the universe expanded, it started to cool and cool very rapidly, in fact. And as it started to cool, more and more atoms bonded with each other and gravity began to pull matter together. And as that happened, the first stars were formed in the universe. So we have these first stars in the universe. We actually very recently discovered one of these first stars with the Hubble telescope. But these first stars were didn't have very long lifespans, but just burned very, very hot. Very, very hot and very, very bright, basically. And then they died quickly. And as the universe continued to expand and cool down, some of these stars began to form into stars like our sun, which burned for a longer times. And as this happened, galaxies began to form as gravity pulled these stars together into collections, basically into clusters. And as stars were pulled into clusters, these galaxies, which are just groups of a lot of stars and some gas and dust, were formed. And so that was during this time, like a couple 100 million years after the Big Bang happened. So we'll discuss galaxies and we'll go into depth about two of the most common or popular galaxies that you'll hear about. But galaxies are collections of stars, gas, and dust, and also include many other things like planets
Hello.
and asteroids. If you have a question, you can raise your hand. Yeah, do you have a question?
Okay. You said, can you please recap on how you initially stated the Big Bang Theory to be?
Yes. So the Big Bang Theory, basically, it states the universe, it's just a theory that we have, but it's the most commonly accepted theory. And it states that the universe started from one single point, one infinitely small single point in which everything was in that point. And then from that point, it exploded outward and formed the universe.
Thank
We
you.
don't know how that point was created or what happened before the Big Bang Theory, but we are pretty sure that what happened after the Big Bang Theory and basically how the universe expanded from that. If anyone has any other questions about what we just went over with the Big Bang Theory and how the universe expanded after the Big Bang Theory, feel free to raise your hand or unmute.
Continue.
So we'll go into galaxies, which are one of the byproducts of the Big Bang Theory as the universe began to cool. And galaxies, as you can see in this image, are just a collection of billions of stars, all they're not actually very close to each other, but because of how many of them and how big they are, they look very, very bright. And that's why you can see galaxies that are very far away. Our sun is currently in a galaxy, and that galaxy is called the Milky Way, as many of you have probably heard about, and exists in a spiral shape, which basically means there's a core, a center, and then all the stars and gas orbit around that core. If anyone has any questions about galaxies or how they work, how they formed, they're formed by gravitational attraction, meaning as stars begin to get pulled together, they will actually start to orbit around their center of mass, or like the center point. And this is what will slowly form galaxies, and that will grow and grow as more and more stars are pulled into the ring. So as galaxies begin to form, something interesting about galaxies that we only discovered a couple decades ago was the dark matter, basically matter that we couldn't see in a galaxy. Because when we looked at galaxies, we saw that galaxies actually should have a lot more mass to pull in all the stars than we see it. So we have to assume that there's mass that we can't see. Basically, there's something we can't see in the galaxy that's also pulling everything into that spiral shape. And according to our calculations, about 60 to 70% of the galaxy is actually dark matter, or matter that we cannot see. So that's something very interesting, and we're currently trying to detect dark matter and detect in our own universe, but we just know that something's happening in these galaxies that cause them to have more gravity than they should, based on the amount of mass and amount of stars that they have. Any questions about that, about dark matter, about galaxies? And
I didn't understand what dark matter is.
dark matter is basically matter that we cannot see, but we know has to exist based on how it influences the stars and the planets around it.
But what is it?
We don't know. We haven't discovered it yet. So we'll go into what galaxies are made of. So I already went over a bit of that before, but stars make up a large part of galaxies, but they're not the only part. And more than half the galaxy is actually dust and gas. So these large clouds, either remnants of stars after they explode or the beginnings of stars. As we learned in our previous week's lesson, stars form from nebula, and when they explode into supernova, they leave behind remnants. And both of those are clouds of dust and gas that float around galaxies and make up a large part of the mass in a galaxy. Mass is basically mass and matter are basically anything of substance in the universe. They're the building blocks of the universe. They're what the universe is made out of. In addition to the gas and dust, most big galaxies, in fact, have black holes, especially one very big black hole at their center, including the Milky Way. And we did go over that as the last stage of a star's life cycle last week. We discussed black holes, but just to recap, black holes are very, very dense objects, meaning they have a lot of mass compressed into a very small point. And because of how much stuff is compressed, they have a lot of gravity, meaning they can affect the stars around them a lot. And in so much, in fact, that light can't escape them because of the gravitational attraction of black holes. You have any questions about black holes or what galaxies are made out of? So clouds of dust and gas are called nebula. And these nebula can come in a variety of colors. You've probably seen some famous pictures from the Hubble telescope or other telescopes of nebula. And they're one of the coolest things to see in space.
Can you show us a picture of a nebula?
Yeah, we discussed that last class. I already showed some pictures. I can go back to that lesson afterwards if you want to. So we'll start with the Milky Way galaxy, and that's the galaxy that we live in, and that the galaxy that our star is orbiting around right now.
Please, how many galaxies do we have?
So in the universe, there are many billions of galaxies, and they all at first, they were all formed from the matter that came out of the Big Bang. But they're very, very far apart, maybe millions or billions of light years apart. So they're very hard to get in between, but we know there's many. And then there's many billions of stars in each galaxy. You might have seen a picture like this one of the night sky with the galaxy. And that's the view of the galaxy from inside the galaxy. As we went in the previous picture, this is a galaxy from the outside. So this is not the Milky Way. This is actually the Andromeda galaxy, which is a galaxy that's close by. And as you can see, we can see the whole galaxy with the core very bright and then all the stars and gas orbiting around that. Since we're in the Milky Way, we can only see one strip or one band of the galaxies since we're part of the disk. And that's why the Milky Way looks the way it does in that picture. Also, very interestingly, is very recently we took an image of the black hole in the center of the Milky Way galaxy. It is very blurry because a black hole is small and doesn't emit light relative to other objects in the universe. But as you can see, the black dot in the middle, that's the black hole in which no light can escape from. And then the glowing parts around the hole are different stars and gas that are being sucked into the black hole and superheated and releasing a lot of light before they fall into the black hole. So that's a very cool image, and it actually took over 3 years to process this image. The data was collected 3 years ago, but the image is only fully processed now, a couple of weeks ago. I mentioned this earlier, but the Andromeda galaxy is also a very popular galaxy outside of Earth. And this galaxy is the nearest large galaxy to the Milky Way. There are some small satellite galaxies that orbit around the Milky Way, but the Andromeda is the nearest large galaxy, and it can actually be seen with the unaided eye if you're in a very dark environment. This galaxy is 2.5 million light years away and was actually where we imaged the first picture of a black hole because of how big the black hole is at the center of this galaxy. Something interesting is that it's in a collision course with the Andromeda galaxy is on a collision course with the Milky Way galaxy, meaning they're moving towards each other and will collide in about 4.5 billion years. However, because of how big galaxies are and because of how relatively small stars are, it's very likely that nothing will happen to any stars. And in fact, the galaxies will pass through each other and the black holes will merge and forming a new, bigger galaxy in which all the stars orbit around. So apart from galaxies, the universe is also more than half the stars of the universe are outside of galaxies, either in star clusters or just wandering around space because they were flung out as part of a collision due to gravity. We also think there might be planets outside of galaxies. However, they'd be very hard to detect because they don't emit light. And the only reason we can normally see planets is because of reflected light from stars. However, we do know that there are stars and actually potentially black holes or roaming around intergalactic space. So it's none of it has any impact on us because of how far away everything is, but it's just something interesting to note that galaxies aren't the only place where things exist in the universe. I'll actually go to our last lesson.
1 second,
And-
are galaxies overlapping each other? Like, how do we know what is one galaxy versus what's another galaxy?
They're very, very
Like-
far apart. So galaxies are only about 200,000. The biggest ones are maybe 100 to 200,000 light years across. However, they're more than 3 million light years away from each other. So the distinction is very clear between galaxies.
Oh, I see.
And
Okay, excuse me.
yes,
Excuse me. Does it mean that these galaxies came into existence before the evolution of human?
yes, this galaxy was formed, I think about 6-7 billion years ago, and humans were only formed maybe like 100,000 years ago. So it existed way before humans, before humanity, basically. And I'll just share a screen.
What is in between the galaxies?
I went over that. It's intergalactic space. And intergalactic space holds almost nothing except for maybe a couple wandering stars or planets, but those are extremely far apart and very rare. So there's nothing. It's a vacuum. Very similar to interstellar space. Also, you mentioned you want to see a picture of a nebula. This one, the clouds of dust and gas that compress to form planets and stars, and also can be the remnants of planets and stars as they explode in a supernova, as we went over last class.
How come they have so much color?
Because the different gases and the different heat emitted, as the light passes through the gas, it emits different color because the gases absorb different types of color, and only certain other wavelengths of color are able to pass through the gases, making it colorful.
Why is it called a supernova?
A supernova was just a name we called a very large explosion at the end of a star's life cycle. I'm not sure exactly the origins of the name, but it basically they're giant explosions that happen after a star dies. And these explosions can be seen with the naked eye if they're close for weeks, basically, because of how big everything is in space. It's like it happens in slow motion when a star explodes. And when it explodes, it'll form a neutron star at the very center, and then the outer layers will get ejected into space and form clouds of dust and gas like nebula, and maybe form another star in the future. Also, here's a conception of what a black hole would look like if you were closer to it. And the different rings you see on top of the black hole are just bending of light of the disk, of the accretion disk, which is just stars swing around the black hole being bent on top and below the black hole.
Is a black hole also solar eclipse?
No, those are different things. Solar eclipses are when the moon goes in between the sun and the earth, and basically the moon blocks the sun from the earth. Whereas a black hole has to do with galaxies and is many times bigger than the sun or the moon, and it works in a different way. However, they do look slightly similar.
What is an accretion disk?
It's just stars and matter that go around black holes. Basically, they orbit around black holes, just as due to gravity, because a black hole tries to pull it in and it goes around. If anyone has any questions about,
Okay.
Yeah.
What's the use of those black holes? As in, what is the advantage or use towards us human?
we don't get impacted by black holes like at all. There are no black holes near us, and black holes are just something we notice in space, and very an interesting object in space, but it doesn't in fact impact us at all and doesn't affect our lives at all. Black holes. Our star does orbit the center of the galaxy where black holes exist, but because the galaxy is so big, the star, our sun will barely orbit in our lifetime, so it doesn't even matter much.
But will we be sucked into a black hole?
No, not in the future. Our sun will actually explode before anything happens like that. But we don't really know because the universe is still relatively young. 13 billion years have passed. However, a star's life cycle can be from 10 to 20 billion years. So most stars haven't even finished their life cycle yet. So
excuse me, it's Aaron from England. How do you know what the lifespan of these stars is to begin with?
Well, we know how we learned here how stars work. Basically, they use nuclear fusion to fuse different hydrogen atoms into helium atoms. And so if we know how much fuel is in a star and how fast it consumes it, we know when the star will eventually run out of fuel and die. So we take the size of the star and we take the amount of hydrogen in it, and then we can use that to determine how long a star will continue to burn before it dies. And as we went over here, a white dwarf. So actually right after white dwarf is a black dwarf, which is a star that's completely cooled down after it dies. And we haven't seen any white dwarfs or black dwarfs in the universe yet. They're just what we basically almost know will happen based on our current understanding of physics and how stars and atoms work. If anyone has any questions, that's all I have for today. I can maybe go over a different lesson if some of you haven't come to the previous lessons about planets and moons. But apart from that, yes.
Excuse me, sir. Good evening. Please, is there anything inside the black hole?
We don't know, but what we assume is basically it's a singularity, which is an infinitely small point that contains a lot of mass. However, you can't tell because not even light can escape a black hole, so there's no way to see anything inside a black hole.
Thank you.
Mm-hmm.
Could you go through the life cycle of the star? I don't know if that was the last class.
Yeah, that was the last class. So as you can see in this diagram, a star will go through two different life cycles depending on how big it is, so how big the nebula is that it first forms from. Our sun is currently an average star, or also called a main sequence star. So it's not as big as some other stars, and our star will, from a stellar nebula, turn into an average star, and then become a red giant as it begins to run out of fuel and expand, basically. And then it'll turn into a planetary nebula as the edges are ejected outward, and the inside will form a white dwarf. The core, basically.
What is the sun? Please, what is the sun made of?
The sun is mostly made out of hydrogen and helium, which are two gases, mainly hydrogen, which are basically two gases that can exist on Earth, but are basically the most abundant elements in the universe. and they're the fuel for the star, basically. They're how stars burn. And a bigger star will turn to a red supergiant, which is like a red giant, but just a lot bigger. And when it explodes, it's big enough that it'll create a supernova, which is a very, very large explosion. That's one of the biggest explosions that ever exist in space. And then if the red giant is big enough, it'll turn into a black hole or a neutron star, depending on how much mass is in the star. And last class I went over each stage from a nebula to a main sequence to a red giant or red supergiant, and then a planetary nebula or a supernova. If anyone has any questions about an individual stage that they would like to see, they can ask any questions. But apart from that, we also went over what stars are made out of and the different layers of stars. So there's a core, and eventually it builds up to the atmosphere or the corona. And the core is where basically the energy comes from and where energy is trying to get out. And it's what balances the gravity trying to pull in and makes a star stable. And it's when that imbalance occurs, when energy runs out, but gravity is still pushing in, that the star will end and either turn to a supernova or other.
And when the star ends, where does all that energy go?
What do you mean the energy?
Like all the stuff from the star.
It just goes into space and forms nebula, so clouds of dust and gas, but it just settles in space, basically.
Okay, thanks.
If anyone has any questions or would like to maybe learn about, we could recap what we learned about planets.
What is the use of the stars on the atmosphere?
The star's atmosphere is basically right after the star surface. It's where all the light passes through and where the solar wind comes from. Basically, the sun's material is ejected into space in all directions, and it's what our magnetic field protects us from. And the atmosphere is just one of those layers of the sun. It's very hot.
Okay, thanks. Okay, thanks.
Something interesting about the sun's atmosphere is that it's actually hotter than the sun's surface. We don't exactly know the reason for this, but we think it might be because of the number of the solar flares that go up into this atmosphere. However, due to our measurements, it's actually 10 or maybe 100 times hotter than the surface of the sun. We also recently sent a solar probe into the sun's atmosphere to measure different things like this, and we found this to be true. Does anyone have any other questions?
Is there something current that's happening with the sun? Are they sending any recent new experiments, or is the James Webb, for example, tracking anything to do with the sun?
No, the James Webb's facing away from the sun, but we have recently sent a solar probe into the sun's atmosphere, and it'll continue orbiting the sun and go deeper and deeper into the sun's atmosphere in the coming years, and taking many measurements like temperature, the magnetic field, and the radiation coming out from the sun as it does its flybys of the sun.
And how is it still surviving?
It has a solar shield, which is basically, it uses the insulation of the vacuum. So it's made out of this carbon fiber material that's very porous. And as those pores are filled up with vacuum, it's a very, very good insulator and protects the solar probe from any heat.
Please, could I
Yeah.
ask a question about future topics?
Yes.
How many galaxies are there on Earth or in space?
Galaxies are basically, the Earth is in a galaxy called the Milky Way, and there are many billions of galaxies in the universe. We don't know how many there are, especially since a large part of the universe, we'll never be able to see a large part of the universe because it's expanding away from us. so fast that even light can't come to us. But we do estimate there to be many hundreds of billions of galaxies in the universe.
Do you have to go through a Milky Way to get to another galaxy?
So we're in the Milky Way galaxy. So the galaxy is the Milky Way. So right now we're in it. And to get to a different galaxy, you would have to go outside the Milky Way and into a different galaxy. However, they're so far away that we currently don't have the technology to even get close to getting out of our galaxy.
Okay. Please, is it possible for we humans to go to another galaxy?
Probably not, because of how far away it would take maybe 1 billion years to get anything outside of the galaxy, because of how far away everything is in space with our current technology. But maybe in the future, if we developed something very fast travel. However, even light takes 2.5 million years to travel between galaxies, and nothing can go faster than light. So it'll be very hard to travel between galaxies.
How big is our galaxy? Like from one end to the other?
It's about 200,000 light years across. And a light year is the distance that light travels in 1 year.
Can I ask you a question about the stars?
Yes.
The sun is an average size star at the moment. Am I
Yes.
right? So then it will expand and get bigger according to the previous.
Yeah. When it dies, basically there will be an imbalance in the forces of the star, and it'll for a short period of time expand and then basically dissipate into space.
Yes. Thank you.
And when it expands, it will consume all of the inner planets, including Earth, but that'll still be in 5 billion years.
Okay, thank you.
Will the sun explode?
The sun won't explode. It will expand, so
Yes.
it'll get bigger and bigger, and then eventually the core will form a white dwarf, and the outer layers will get ejected into space. But it's not big enough to explode. Are there any other questions? You can ask about anything related to astronomy, not just the stars or galaxies.
Okay. Sir, please, what can be the cause of ozone layer depletion?
What did you
As
say?
in the much, I said, what can be the cause of ozone layer depletion? That's the much effect of sunlight towards us.
Ozone layer. Well, the ozone layer isn't actually getting depleted that much anymore, but a lot of human activities, like different chemicals we put out into the atmosphere, can cause the ozone layer to deplete. And the ozone layer protects us from the solar wind and from the rays of the sun.
Excuse me, sir. What is the stellar nebula made up of?
Stellar nebula are basically clouds of gas and dust in space.
Thank you.
So they exist everywhere, and they're the building blocks for stars and planets and everything that forms inside of a galaxy.
When the
Okay.
sun explodes and form little white dwarfs, will it affect the Earth and us humans?
The sun won't explode, but by the time it forms a white dwarf, we will be gone. It'll already have expanded and gone, encompass the Earth. However, this is in 5 billion years, so it's very, very far in the future. However, the sun will eventually expand to a size where we won't be able to live on the Earth anymore.
When will that be?
So basically the oceans will evaporate in about 2 to 3 billion years because of the sun growing and getting hotter and hotter. And in 5 billion years, the sun will have encompassed all Mercury, Venus, and Earth, and will be turning into a planetary nebula.
So what is the maximum amount of time that the humans will be able to be on this planet?
That's hard to tell, but it's definitely not going to be because of the sun. There are other factors, like the different resources are available on Earth and other causes that could influence that.
Okay, you're basically trying to say that in every galaxies that there are black holes, or is it only in the Milky Way galaxy?
In most galaxies, there are black holes. Not very small galaxies, however, in almost all big galaxies, there are black holes. Yes.
Are black holes dangerous?
Black holes are not dangerous to us because they're very, very far away, so they don't affect us at all.
If you eventually run into a black hole, will it damage you or
Yeah, you'll
Will?
get sucked into a black hole. We don't really know what exactly happens, but yeah, you won't be able to come out of the black hole if you get sucked into a black hole.
are black holes one of the disadvantages of traveling to space?
No, because black holes are so far away that they will likely never affect humans in any way. So black holes are not even a factor when considering space travel.
Okay, thanks.
Are there any other questions? Any other questions about anything astronomy related, or about, it doesn't have to be stars or galaxies? Well, in the future, we're going to be talking, we already did galaxies in the universe today, but we will go into depth about space exploration. So that's the different missions to Mars and Jupiter and the sun that we've undertaken. And we'll learn how telescopes work and how we can basically see these stars and these galaxies that are so far away.
Did Pluto turn to a white dwarf?
No, Pluto didn't turn. We named it a different way, basically. So we originally thought it was a planet, but it's actually too small to be a planet, and so we named it a dwarf planet.
Thank you very much. This is all very interesting.
Yes, we learned a lot. Thank
You're
you.
welcome. Well, that's all I have for today. So if no one has any other questions, then that's it.
Thanks.
Thank you.
Thank you. It's great.
Thank you.
Okay, you're welcome.
Thank you very much. Thank you.
Thank you, Luca.
Oh, you're welcome. I'll be ending the meeting now.
Bye.
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 Bye-bye.
Thank you. Bye-bye.